So what we're doing today is we are still looking at systems of equations. We're going to go away from the word problems. So these systems have already been written for us. But today we're going to learn a different way to write these systems of equations. Or not a different way to write them. We're going to learn a different way to solve systems of equations. So right now, how is the only way you know how to solve systems of equations? To find where the two lines meet. We graph them, right? You take these two lines, you graph them, and you find where they intersect. Okay, now we're going to show you a different way to solve systems of equations. This way is called substitution. So we're going to solve these four systems of equations by using substitution. So what is a substitute? Takes the place of something in a different position. So look at the first one. You see I've got two lines. I've got x plus 2y equals 8, and I have x equals negative 5. To use substitution, we need to find an equation where the variable is by itself. We have that on the bottom. We have x is equal to negative 5. Okay, so in the second line, x equals negative 5 has a variable isolated. We know what x is. What is x? Negative 5. So guess what? In the first equation, instead of saying x, I'm going to substitute negative 5 in its place. So now instead of saying x plus 2y equals 8, I'm going to say negative 5 plus 2y equals 8. Now, I have an equation with just one variable that I can solve. So I need to get y by itself. So to get y by itself, I can add 5. That tells me 2y equals 8 plus 5, which is 13. And now y is being multiplied by 2, so I divide by 2. That is a decimal. It's going to be y equals 6.5. So what am I looking for? I'm looking for the place where these two lines meet. So where's the x value that they meet? It's at negative 5. Right? Look, it tells me x has to be negative 5. Where's the y value where they meet? 6.5. So if you were to graph these two lines, that's the point they would meet. Right, this is called substitution. Do you guys want to try the second one, or do you want me to do it? All right, I'll give you a 30-second head start. If you feel good about it, go for it. Okay, so I'm going to go ahead and start the second one. So I already have a variable by itself. I know that y is -1. I'm going to plug -1 in for y. So that would be negative 1 equals negative 7 times x plus 13. And now we want to get y by itself. So because we're adding 13, I can undo adding 13 by subtracting 13. That gives me negative 14 equals negative 7x. X is being multiplied by negative 7, so I divide by negative 7. That tells me x equals 2. So now I'm looking for the point where these two lines meet. I now know the x value where they meet is 2, and then the y value where they meet is negative 1, because it tells me y has to be negative 1. So the point where the two lines meet is at 2, negative 1. So the first thing I need to do is I need to pick an equation to isolate a variable. I'm looking at 3. So I don't have a variable by itself. So let's pick one to get by itself. I would choose the top one. And so to get x by itself, I need to divide by 3. And so that tells me x is 8 over 3. All right, we could make that into a decimal, but it's an ugly repeating decimal that we really can't use. So let's just leave it as a fraction. So I found x must be 8 over 3, which means I know the x value where they meet. Now I'm going to take this info and plug it into the other equation. So I can plug in 8 over 3 here for x. So that would give me 3 times 8 over 3. That's what I'm substituting in. Plus y equals 15. 3 times 8 over 3 is just 8. And now y is being added by 8. So to undo that, I can subtract by 8. And so that tells me y is equal to 7. So now the point where those two lines meet on the graph would be at 8 over 3, 7. All right, then let's try the last one. Do I have a variable that has been isolated? Is there a variable by itself? There is. Right here it tells me what y is equal to. Y is 2x minus 7. Okay, but also if I look at the second equation, look at it. It only has one variable to start with. Right? There is no x. So the easiest thing to do would be to take the second equation and solve for y. So if I take 4 plus y equals 12 and get y by itself, that means I'm going to subtract 4. That tells me y must equal 8. So now I know on the ordered pair where they meet, the y value is 8. I'm going to take that 8 and plug it into the other equation, which in this case will be the top one. And so now that would give me 8 equals 2x minus 7. Now let's get x by itself. So we would add 8. That's wrong. Add 7. So that would give me 15 equals 2x. And now x is being multiplied by 2, so I would divide by 2. So x is 7.5. So the ordered pair where these 2 points meet would be at 7.58. Okay, so if you did that... No, I'm going to do it so I can record it. You plug 2x minus 7 in for y. So that would give me 4 plus 2x minus 7 equals 12. Then you could combine negative 7 and 4 is negative 3. Then you would add 3.
It's almost less. I think it's almost less. Well,
So now you found x is 7.5?
yes.
All right, now you got to go find what y is.
Yeah. Then you plug y equals 2 times 7.5 times 7.
Yep, you can do that. So you could take this 7.5 and plug it in here. Or you could just take the bottom one because it only has a y and get y by itself. Right? I mean, either way. And so that would be y equals 2 times 7.5 minus 7. So that is, I'm going to go up here to work it. That's going to be y equals 15 minus 7, which is y equals 8. So again, there's more than one way to do this. You just have to follow the math.
We could just plug that into our calculator.
So here I've got 5x minus 2y equals 26 and y plus 4 equals x. So now I've got two variables in both equations. This is normal. This is the way they normally look. Is like this. So again, graphically, I could just graph these lines and find where they cross each other. Right? But that's going to require me to get them in slope-intercept form. Get y by itself. So as I'm doing that, I could just use this. I could use substitution. Do I know what x equals? I do. It tells me. X is the same thing as y plus 4. So now I can plug y plus 4 in for x in the first problem. So that would be 5 times x. But I know x is y plus 4 minus 2y equals 26. So now you see how I only have one variable now? There's no more x. There's only y. So I can distribute. 5 times y is 5y. 5 times 4 is 20. Minus 2y equals 26. Do I have any like terms? Yes. 5y minus 2y is 3y plus 20 equals 26. Now I just have a single y, so get it by itself. So I could subtract 20, which tells me 3y equals 6. And then divide by 3. Y equals 2. Correct. Because remember, I'm looking for the point where they cross. So I know the y value where they cross is 2. So now I need to plug that in to find x. So you can plug it into either one of your original equations. I would plug it into the bottom one because it looks simpler. Right? So I can plug in 2 for y right there. And so that would be 2 plus 4 equals x. So the x value is 6. So that means the solution to my system of equations is 6, 2. Yep, I'm going to let you try the next 3 on your own. Okay, I'm going to go ahead and work these out. Hopefully you are finished or close to finished. So in the first one, we would plug 2m plus 10 in for p. Because p is 2m plus 10. So that would give me 2m minus 2 times p. But p is 2m plus 10 equals negative 6. So I've substituted 2m plus 10 in for p. Now I need to distribute. So negative 2 times 2m would be negative 4m. Negative 2 times 10 is negative 20. So I've got, bring down this 2m. Now I've got rid of the parentheses. Do I have any like terms? 2m minus 4m is negative 2m minus 20 equals negative 6. Now I have a single variable, m. So let's get that m by itself. Add 20. So negative 2m equals 14. Divide by negative 2. So m equals negative 7. So that's just the first part. Right now I know my ordered pair, the m value is negative 7. Now I'm going to take negative 7 and plug it into one of my original two equations. I think the bottom one's easier. So I would plug it in there for m. That would tell me p equals 2 times m. But I now know m is negative 7 plus 10. And then simplify. 2 times negative 7 is negative 14. And then negative 14 plus 10 is negative 4. So my ordered pair, the point where those two lines meet, is at negative 7, negative 4. Questions? Again, this is called solving a system of equations by substitution. All right, if I look here at the third one, do I have a variable by itself? I don't, not yet. So I either need to get d by itself or f by itself in one of those equations. I think the easiest way to do that is to take the top equation and get d by itself by dividing both sides by 2. And so that would tell me d must be equal to 4f. Huh? What? Why? Are you good with me picking the top equation?
Yeah. I don't know how to do it. Just do it.
So you've got to get a variable by itself. So I chose to get d by itself in the top equation. So just divide by 2 because d was being multiplied by 2. Yes? And now I have d by itself. D is 4f. So now I can substitute in 4f into the other equation. So in this case, that would be the second equation. So I'm plugging 4f in for d. And so that would be 18 minus 4f equals 2 times d. But now I know d is 4f. Now, 2 times 4f, that would be 8f. And now I've got variables on both sides. I have an f on the left and an f on the right. So I need to choose to eliminate one of those. So I would get rid of the negative 4f. I can do that by adding 4f. You see how all these solving equation skills you're still going to be using? You better get good at them. So this would be 18 equals 12f. Now I have a single variable, f. It's being multiplied by 12, so I can divide by 12. That tells me f must equal 18 over 12, which I reduced to be 3 over 2. You could do 1.5. All right, there's no one right way to do it. So now I'm halfway done. Right? I know what f is. F is 3 over 2. So I'm going to take this and plug it in to either one of the original two equations. I'm going to use the top one. I think it looks a little simpler. So if I plug in there, that's going to tell me 2 times d equals 8 times f. But I now know f is 3 over 2. So 8 times 3 over 2 is 12. Well, you can plug that in your calculator. Now d is being multiplied by 2, so I need to divide by 2. That tells me d is equal to 6.
Which one's X?
Alphabetical. Which one comes first? D or F? D. And then the last one. It tells me z is 3w minus 2. So I'm going to plug that in for z in the first one. So that would be w plus 1/7 times z, which is 3w minus 2, equals 4. Distribute. That would be w plus 3/7 w minus 2/7 equals 4. Boy, this is going to get ugly. Do I have any like terms? I do. W and 3/7 w is 10/7 w. You know how I did that in my head? Right here, this is 1w, right? So I can rewrite 1 as 7 over 7. So this is 7/7 plus 3/7, which is 10/7. When you add fractions, you keep the denominator the same. I tell you this, just put in your calculator. 1 plus 3/7. Okay, it'll give you 10/7. This is where if y'all would learn your fraction rules and be able to do them in your head, you can do them quicker than your calculator can. Right, but
I knew this. I think you told me about it last year.
yeah. Now I have a single variable, w. So let's get that w by itself, which means I need to add 2/7 to both sides. I don't know, why did that not move with it? Oh, why did that not move with it? Okay. So I'm going to add 2/7. That cancels. That leaves me with 10 over 7w equals 4 plus 2/7. That would be 30 over 7. Again, calculator. Just put it in. W is being multiplied by 10 over 7, which means I want to divide by 10 over 7. The problem is we can't divide by fractions. Your calculator can. Your calculator will do a fine job, but I don't have a calculator. So instead of dividing by a fraction, I have to multiply by the reciprocal. So these cancel. W equals. These cancel. 30 over 10 is 3. Huh? Absolutely. Plug it in your calculator. You can either learn to do fractions in your head like I have, or plug it in your calculator. Plug it in your calculator. Now I know W is 3. So now I got to plug that in. Hello. Hey. Okay? Okay. Thanks. Okay. So I plug in 3 for W. Hopefully you've already done this. Z equals 3 times 3 minus 2. So Z is 9 minus 2, which is 7. So my ordered pair would be 3, 7. Okay, so now we have 4 variables and 4 equations. Huh?
4D.
So do I have any equations that just have one variable? The last one. 2W equals 8. So we can solve that one for W, which means W equals 4. Now that I know W is 4, I can plug that into any of the other equations. So if I plug it into the next to last one, then I only have one variable to deal with. That tells me Z is equal to 4 plus 1, which means Z is equal to 5. So now I know 2 variables. I know W and Z. So if I plug into the one above them, if I plug 4 in for W and 5 in for Z, that would give me Y equals 2 times 5 minus 3 times 4, which means Y is 10 minus 12, so Y is negative 2. And then I could take this, and now I know 3, and plug all 3 of them into the top equation. There goes Y, there goes Z, here goes W.
I mean, this literally all it is plugging in stuff and doing simple math.
So that would be 3x plus 2 times negative 2 minus 5 plus 5 times 4 equals 20. That would be 3x minus 4 minus 5 plus 20 equals 20. The 20s cancel, which means 3x minus 9 equals nothing. So 3x equals 9, so x equals 3. So the ordered quadruple would be 3, no, it'd start with W. It would be 4, 3, negative 2, 5.